What's up, everybody? Welcome back to another live stream from the Scalar Learning Channel, and we are back at it for SAT week, and we are continuing a series that I'd started some time ago after a lot of requests of people saying, "Hey, can you finish this series and go through the medium level problems?" And this is our SAT Khan Academy series. I've done this in the past for the old version of the SAT. I actually think this is going to be even more effective and way better for the digital SAT because I think that Khan Academy, the quality of the problems has increased dramatically for this SAT. As I've been going through and using these more with my students, I'm really impressed with how they fine-tune the questions and they're much more closely aligned with the actual questions or question formatting and style on the SAT. So, as of yesterday, I completed the entire level of foundations. This week, I'm going to try and do my best to do all the medium if I can. If I'm really ambitious, maybe I can even start on the advanced level problems. But at a minimum, we're going to knock out 8 categories right now, back to back, as there's 8 subcategories in the algebra subtopic. So if you want to see all 8 categories, they're listed in the description. You can check that out. And without further ado, let's do it. So we got 8 categories, 4 problems each. So it's gonna be 32 problems, and I think we can knock them out in the next hour before I got to jump off to my next tutoring session. So without further ado, let's go. Last but not least, if you are looking for the top resource for digital SAT content, check out this banner right here, the SAT Crash Course. They're my official partner. You can use the code SCALAR for 20% off. Moreover, I have video explanations that you can only access by signing up and using their practice tests. I have video explanations for the first 10 practice tests, so I would highly, highly recommend you using them. I use it with my students as well. To me, there's no question. It is the best quality practice test available on the market, and that's what you want. You want high-level, really representative practice tests. So you go in on the day of, let's say it's this Saturday, and you're just like, hey, I've done this a million times, and you feel totally at ease, calm, so you can do your best. All right, without further ado, let's hit it. Boom. Solving linear equations and inequalities, medium level. All right, so in this case, what is the solution? This is just straight up variable isolation. And let's write it out. So what are we doing here? We need to isolate x. So first we're going to minus 1. Let's see if I can make this a little thinner here. 1 second. Doop-a-doop. Okay, minus 1 from both sides. Ooh, that's too thin. I don't like that. Hold on. Maybe like 4, 5, 2. I don't know. Is that good? That's okay. Hold on. Let's go. Why can't I? 4. There we go. That's not bad. So minus 1 on both sides. That cancels out. Negative 6 minus 1 is negative 7, right? 2 negatives add together. And then last but not least, we need to divide by negative 5. And we've got x equals, the negatives cancel out. We got x equals 7/5. Now, again, on the SAT, you can enter a fraction just like this, 7/5. You can also enter the decimal version, but that is it. All right, boom. Next, here we go. What? This is a weird one. Okay, so this one you definitely want to use a calculator, so we could use Desmos, because all we're doing is we're just evaluating this on the... Actually, I might be able to do it without Desmos, just for fun. Okay, so we got to do order of operations, right? So we're going to do the subtraction first. Don't add these together. I got to say, though, this doesn't feel like a very good, authentic SAT question. I'll just be honest, even though I just went out and said how they've gotten better. This is definitely not something you're going to see on the SAT, but let's do it anyways, because you can actually type... Actually, you know what? Let me show you how to do this in Desmos. You can literally type this equation in verbatim, but notice this little trick at the end. They said, what is negative j, not j? So you got to be mindful of that. So check this out. If we go into Desmos, boop, boop, boop. Okay, so I'm going to type it in verbatim. 2, watch this. Let's say 2 plus 2 times 8347, 8347 minus, 1 second, 4783. 3 equals negative 2j. I think I have it exactly how they did it. Okay, so you notice it kind of gives this weird thing, this thing here. So a lot of times if you're solving for a variable that's not x, just change it to x, and then it's going to work. Now, what you're going to see here, when we zoom out, you're going to see a line where the value of x is. So that's where my value of x, it's right there, negative 3,565. But again, remember, we're not solving for x, we're solving for negative x. So we can just simply negate that, and it should be positive 3565. For the win, boom, done. Okay, next. Now we got an inequality. To solve an inequality, again, all we're doing is isolating x. So that's a common principle that you'll see over and over. And by the way, I'm going to state the principles, the common trends, like the things that you want to do in every situation when you see a certain problem like this or that, so you can just go into autopilot. A lot of being successful on this test is developing the muscle memory. So you see a problem type and you know exactly what to do immediately, and you just go without having to think or contemplate too much. Now, again, I could graph this in Desmos, but so much easier if I just solve it by hand. So I'm going to subtract 9 from both sides, right? We're just trying to isolate. Boom. We got -6 is greater than -1/2 times x. Then we're going to get rid of the -1/2 by multiplying both sides by -2. That kills that. -2 times -6 is 12. But also remember, when you multiply or divide both sides of an inequality by a negative, you flip the inequality. And then so we have, and this is the same as x is greater than 12. I always read the inequality with respect to the variable x is greater than 12, which is option B. And that is how you do it. Done. Boom. Last but not least, this one. So again, we can type this straight up into Desmos. I think it's faster to do by hand, so I'm going to do this. -8 from both sides. 8x equals 100. Divide by 8. Divide by 8. I can do this mentally. It's like taking half 3 times. So it's 50. Half of that is 25. Half of that is 12.5. So our answer should be 12.5 for the win. Boom, done. Okay. So now we got that one done. That's level medium. Now we're going to move on to subtopic 2, linear equation, word problems. Without further ado, we're going to start in 3, 2, 1. Let's go. All right, let's bring this over so we have more room. All right, a pizza delivery worker purchased a used motor scooter that had been driven 12,000 miles. He drives, hold on, I don't need this yet. He drives the motor scooter only on days he is working, during which he drives an average of 50 miles per day. After D days of pizza delivery, the motor scooter has been driven 25,000. Which of the following equations best models the situation? All right. I like to create my own equation. I don't just my thing is I don't just jump into the answer choices. So let me show you how I would do this. Gosh, this thing is takes up so much space. Okay. So he starts having driven 12,100. Then adding onto the mileage, he's doing 50 miles per day. Okay, and D represents day. And then after D days, the total mileage is now 25,000. So I've just sort of written out my equation, aka my relationship between all these values like so. And now I can just match, right? I'm just trying to look for this equation or some variation of this equation. But look at this. Literally how I wrote it is presented right here in option D. And that's why I think this is such a great strategy, because the majority of the time you're going to see it as is. It's faster than trying to look at each choice, in my opinion, and be like, does this make sense? Does that make sense? And even if I didn't see that exactly, I know that equation is right. So I know that the correct one would have to be just a manipulation, meaning maybe they move some of the terms around or whatever according to the rules of algebra and arithmetic. So, all right, Dimitri is helping. Okay, let's do the same strategy here. Dimitri, let me move this down. Dimitri is helping to plan for the school. Each performer of the talent show has 6 minutes for his or her performance, which includes transition time between performances. The introduction for the talent show is 24 minutes. Okay, so we got an introduction at 24 minutes, and then each show is 6 minutes. So this is now my expression for the total amount of time. Introduction is 24 minutes, and the entire show, including the introduction. And so the whole thing, so that's the introduction plus all the individual ones, added up is 150. How many different performances can they accommodate? Again, it's already built into my equation. X is the number of individual performances, right? Because each one times 6. All I got to do is solve for X. I'm going to use Desmos on this one just for fun. So 24 plus 6x equals 150. Hold on. 24 plus 6x equals 150. And oops, we should zoom in, but there's my answer. 21 is the winner. A, boom, done. But let's double check mentally. 6 times 21 is 126. Plus 24 is 150. That's how we do it. Okay, next. Phyto remediation is used whatever. Irrelevant. Suppose a crop of brake ferns can remove 15 milligrams. Okay, so removing. Hold on. Watch how I'm going to piece this together. It's removing 15 grams per week. Wait. Can removing 15 grams. No, sorry. 15 milligrams per square meter. Excuse me. 15 milligrams per square meter of a particular pollutant from the soil in 20 weeks. Okay, so it's 15 per 20 weeks. Okay. Okay, this one might be a little more complicated. Let me think it through here. After 20 weeks, the ferns are harvested and a new crop is planted. So we do remove 15 milligrams. Okay. A crop of brake ferns can remove 15 milligrams. Okay, got it. So it's removing the pollutants. I'm getting it. After 20 weeks, the ferns are harvested and a new crop is planted. If C represents the number of crops of brake ferns needed to phytoremediate soil contaminated with 15 milligrams down to healthy levels of 5 milligrams per square meter. So we're at 170. We need to remove all this stuff to get to 5, okay? Which equation best models the situation? And we're removing, C represents the number of crops. So then C represents, they don't give a time thing. So they say in 20, oh, I see. So we're only doing we're just assuming it's 20 weeks. So almost the time is irrelevant. So we're just basically saying 15 per crop. And there's my equation. So it should be 170 minus 15C equals 50. So again, right? I hope that made sense. This is not, if it said the amount of weeks, then maybe we could have, something different. But it doesn't say per week. It just says per crop. So 15 milligrams for every crop over 20 weeks, but they're talking within a 20-week period. So the time, as I'm saying, is irrelevant. I hope that makes sense. Now we look at the answer choices. I see this exact one in C. That is how you do it. Done. Okay. Last one. I don't like word problems. They're just not fun. Felipe is saving money for a class trip. He's already saved 2. But notice the strategy. What am I doing with the more complicated ones? I'm extracting the numbers and the information and reformatting it in a way that makes sense to me. And that's a big key because I historically have not liked word problems, but this is how I've sort of come to a mastery level with them as well. Has saved, okay, he's already saved 250. So that sounds like my y-intercept, my initial value. So we need a positive. It's got to be D already. But anyways. Let's not look at the equation. Let's follow our protocol. So we save 250. To save more money, he gets a job where he can add 350 to his savings for the trip. Let M be the number of months that Felipe has worked his new job. Each month. I missed that. So 350 per month times each month. If Felipe needs to save, meaning needs to have a total of 2,700, which equation models this? And as I mentioned, it's this one. But again, they don't have this exact match, but they reconfigure these, which we can do with addition, commutative property. We can swap it, and we still maintain the integrity of the equation, which means D, therefore, is the winner. Boom, done. Okay, so we got 2 out of 8. We're on our way. Okay, let's keep going. Next. What is this? No, I don't want this lesson. Okay, 3. Boom. Practice problems are the best way to prepare, good use and good work through these practice problems, checking the explanations when need be, trying to figure out incorrect answers. So if I get any wrong, we will dive into it together and use that as a way to learn. All right, here we go. Manufacturer pickles has fixed monthly cost, meaning we have a baseline y-intercept of 10,000, and then it says additionally each jar of pickles that the manufacturer produces costs 75 cents. So we're spending 75 cents per pickle jar, which we said down here. P is the number of jars of pickles, and all of this together equals the total cost. That's it. I see it right here in option A. Boom. And again, another variation could have been 0.75 P plus 10,000. That's it. Done. All right, the amount of paint P in pints that an art studio can buy with D dollars is given by the equation. What's the best interpretation? Now, linear equation, I want you to think immediately. There's only 2 pieces to a linear equation. The y-intercept, meaning the constant by itself, and the slope, okay? The slope, how do I know it's the slope? Because it's multiplying the variable. So this is my slope, meaning this is my rate of change. And so I should be looking for language that represents that. Hold on, now let me read it again. So to me, this is saying we're getting 4. Wait, can buy with D. So they must already have. This is the amount they must start with, and this is the amount per dollar they can get. So we can get 4/25 gallons of paint per dollar, right? Because if you have $1, you get 4/25. If you have, $25, you'd get 25 times that, which would be, I think actually 25. Or no, it would be 4. Sorry, 4 more gallons of paint. So let's see. the paint costs 4/25 of a dollar per pint. No, $1 can, yeah, it's this one. $1 can buy 4/25 of pint of paint. That's what we just said, right? And the other way to think about it, it's 4/25 paint per dollar. It's always, the slope is always the amount of y per 1x, if that helps. I think we got it right. 4/25. Oh, wait, sorry. What did I say? $1 can buy 4. Right. So 1, 2, there we go. Boom, done. Okay. Next, clothier who only makes shirts can make a shirt in 4 hours and a pair of pants in 6 hours, which are the following equations. Shows the number of shirts, the number of paints can make in 40 hours per week. One way that we can take a shortcut in this one is if you have 40 hours per week, you can kind of say like, well, if it takes them 4 hours to make one shirt, in 40 hours you can make 10 shirts, right? Meaning, if I plug in, what is P? Hold on. Yeah. So S equals 10, okay, when P equals 0. Like if I do no pants, I should be able to make 10 shirts because I'm using all 40 hours in there. So let's see. See, this would work for B. So not A, because if I plugged in 10 here, that'd be 60. If I plug in 10 here, yeah, it's got to be B. Okay, but let's think about it more. And then if I did per 6 hours, so like I should be able to make, what is that? 6. I should be able to make 6 2/3, and that pants if I make no shirt. So if I plug in 0 here, we would get 6 2/3. A fraction. Hope that made sense. Is there another way to think about it? I will make a December prediction, by the way, Al-Wasi. It will be out on Friday, okay? I'm just trying to think if there's anything else. Yeah, that's it. Now, you might think we should be looking for C or D, right, where it's something divided by the number of hours, but that would be true if we were like, hey, equals a total number of clothing items. That's not what it is. It's equal to total number of hours. So one shirt would cost me 4 hours. Almost think about it as like a total value of hours. One shirt would cost me 4 hours, 2 shirts, 8, etc., which means B is the winner. Okay, one more word problem. Here we go. Hopefully, we'll do some more fun equations after this. Now they give us an equation, and it says the total amount A in $1,000 scholarship money. So A is the scholarship money throughout its history at S semesters after the summer of 2000, given by the equation. What was the total amount of scholarships in $1,000 given out in the college up to the summer of the year of 2000? Wait. Yeah, so they just basically, so S is the semesters after 2000. So if it's 1, it'd be like 1 semester after, 2, it'd be 2 semesters after. But they're saying right up to the summer of the year. Yeah, so it says after the summer of the year of 2000. This is up to the summer of the year in 2000, meaning no semesters have passed, meaning S is 0, meaning goodbye. They just want the y-intercept. 2, 4, 50. That's how you do it. Okay. Boom. Yeah. Let's move it along. 2, 4. Here we go. Graphs of linear equations and functions. Boom. All right. The equation 2y minus 7x equals 5 is graphed in the xy plane. What is the slope of the line? I don't even need to graph this, but you can graph it if you want. I think it's way easier to just put this into slope-intercept form. 2y equals add 7x to the other side, then divide by 2. Y equals 7 over 2x plus 5 over 2. This is my y-intercept, but they said the slope, which is 7 over 2. That's it. Gotta know slope-intercept form, and that's one of the things I tell my students. Don't be so like, I gotta do everything in Desmos because Desmos is amazing. Some of these can be done faster by hand if you got a good grip on the material. Which of the following is an equation of this line? I'm gonna piece it together straight up from the graph. Y-intercept of -2, a slope of, let's see, we got 2 nice points here and here, so watch how I reconstruct the slope. To get from there to there, and I'm choosing those points because they're nice and identifiable on those crosshairs. I'm going down 2 over 1, 2, 3, 4, 5. So the slope is -2 rise over run, which is 5, and then times the variable x, and this equals y. Let's see which answer choice is here. Oh, can't go down. Okay, this thing is really annoying. Okay, y equals negative 2/5 x minus 2. Y equals negative 2/5 x minus 2. That's how you do it. Boom, done. What is the slope? Same dealio. Let's get it into slope-intercept form. Isolating y. Oops. So we got negative 6y. Oops. Negative 6y equals minus 8x from both sides. Negative 8x plus 1. Divide by negative 6. Y equals negative 8 over negative 6, which is positive 8 over 6, which reduces to 4/3. Tell me why you can't see the question. Oh, is it because this thing is blocking it? There we go. Sorry about that. Tell me if that's better, or tell me if you need me to zoom in. 4/3 x and then minus 1. Minus. I got to get a better app for this drawing stuff. Minus 1 over 6. And again, my slope is 4/3. My y-intercept is negative 1/6. So slope is 4/3. Hope that made sense. That's how you do it. All right, last one. Which of the following statements below is true? All right. Now, again, they're asking about slope, and they're asking about, x-intercept and y-intercept. Actually, this isn't, all right, thank you. This is an interesting one. All right, let me move it down here. So first, they're asking about x and y-intercept. Let's address that first, because this is in standard form. Now, a lot of times I like to go straight up to slope-intercept form, but to find the x and the y-intercept, it's actually easier in standard form, because the y-intercept is when x is equal to 0. The x-intercept is when y is equal to 0, right? And all you got to do is plug and chug and solve for the remaining variable. So plug 0 in, goodbye. 10y equals 30, which means y equals 3. Now we'll do it again. Hold on. Let me erase this. Oh, it's not going to let me. All right. So I'm going to have to get a better app next time. This is just kind of weird because I don't even know how to erase this. So anyways, we'll just say now we're going to leave the 5x in, 0 this out. 5x equals 30 divided by 5. X equals 6. That's my x-intercept. So we got an x-intercept of 6. And it's right here. It's D. So D is the winner. Now to get the slope, I would have isolated y. I would have minus 5x and then divided by 10, which would be negative 1/2. But they don't have that as an option. So we got our answer. That's how you do it. I got to say for those ones, like I've never seen, they are a little bit missing the mark in my opinion in terms of representative questions. Like I've never seen a question like this on the actual SAT. I think the concepts being tested are good, but I'm just letting you know in full disclosure. All right, let's keep it going. Halfway done. We're going to skip this quiz. All right, 5. Here we go. Boom. Let's go. Now we're in the system of equations. This will be more fun. Consider the system. How many solutions does it have? So there's a couple ways we can do this. Number one, we can graph it in Desmos. Actually, I'll do that for the first one. The other thing is, if you just look at the slopes and the y-intercept, if the slopes are different, let me see. The slopes are going to be the same, actually. So if the slopes are different, it's got to be one solution, but they're different. And I'll show you why in a second. If they have the same slope and the same y-intercept, then it's infinite. It will never be 2. And then if they have the same slope, different y-intercept, they're parallel, and it will be 0. But let's do it in Desmos just so you can see. So negative, I think it's going to be infinite. Negative 6x plus 4y equals 2. And then we got 3x minus 2y equals negative 1. 3x minus 2y equals negative 1. All right, you see how they're right on top of each other? Right? If I turn this off and I see just the green one, turn it back on, it's right on top of each other. That means infinite solutions, meaning they're the same line, so they intersect an infinite number of times. That's it. I'll show you how to do one of these by hand as well. Okay, next. What is the value of y? All right, so this one I'll solve by hand. I know you said you couldn't see the question. Let me move this down. So what is the value of y? So we're going to solve this, and we're going to solve it either via elimination or substitution. Since y is already isolated up here, I'm going to just say, okay, y equals this. Well, y should be the same for this equation as well. So we're just going to replace it with x, and this is going to allow me to solve for x. Now, they are asking to solve for y, so we're going to have to remember that at the end to plug it back in. But this will get us closer. So we got 2/3 x equals, instead of y, 4/7 x plus 5/7. I don't like these denominators and fractions and all that, so I can get rid of all of them by multiplying by the least common multiple of 3 and 7, which is 21. Boop, boop, boop. 21 divided by 3 is 7 times 2 is 14x. 21 divided by 7 is 3 times 4 is 12x. And then 21 divided by 7 is 3 times the numerator 5 is 15. Minus 12x from both sides, we get 2x equals 15. Divide by 2, divide by 2. X equals 15 over 2. But that's not the answer because that's x. We need y. So now I'm going to plug it back into this equation right here. Y is equal to 4 over 7 times, instead of x, we're going to plug in 15 over 2. Let's simplify. 2, we can divide 4 and 2 by 2. So that's 1, that's 2. 2 times 15 is 30. Oops. And we've got 30 over 7 times 1, which is 7. So that means B is the winner. Done. Again, you could have, honestly, it might have been better to just plug this into decimals because of all the weird fraction stuff, which you could have done, but I wanted to stick with that there. Okay, this is an interesting one. Consider the system of equations where A is a constant. For what value of A are there no XY solutions? Again, it's going to be when they are parallel. So remember this. When you see something like this where they say, hey, we're trying to figure out, for what value of the constant are these going to have no solutions or something? We need same slopes, different y-intercepts, but you usually don't have to worry about the y-intercepts. It should work out that the value of the constant that gives you a parallel slope will invariably give you different y-intercepts. So check this out. I need to divide both sides by a in this one to get it into slope-intercept. So we got y equals 2 over ax plus 1 over a. Now the slope is whatever's multiplying the x, which is 2 over a. The slope in my bottom one is 2. So for them to have the same slope, right, for them these two to be equal, you can see obviously a has to equal 1. And if a equals 1, it's going to be 1 over 1. The y-intercept's going to be 1 here. The y-intercept's going to be 2 there. So as I mentioned, those y-intercepts are going to kind of work out naturally. But anyways, a is equal to 2 to get the same slope. Hey, oh, not 2, 1. God, I typed in the wrong thing. Sorry, guys. That was a typo. Apologize. All right. Next one, last one. Here we go. Watch those typos, by the way. It's a good sign to remember to be extra careful on the digital SAT. Okay, consider some equations. What is the value of x plus y? Let's do this one in Desmos. Okay, so we're going to put in both equations. 8x minus y equals 12. And we're going to put in the second one, 2x minus 6y equals 3. And we got our nice solution, which is here. Let's zoom in a little bit. Sorry, it's right there, which is 1.5 comma 0. But then they said, what is x plus y? So it's 1.5 plus 0, which is 1.5. Let's just double check. 1.5 times 8 is 12 minus 0 is 12. 1.5 times 2 is 3 minus 6 times 0 is 3. They both work in both equations. Boom, done. All right, next, 6, here we go. Boom. Michael's planning to join a local gym. Oh, more word problems, bro. They're not fun. Okay, here we go. Can you solve some exponential functions, coefficient based? Yeah, I'll do that later tonight or tomorrow, but that will be coming. I don't know if it makes sense or not. If I get 2 hard questions wrong in M2, is there any possibility to get an 800? I don't know, because the College Board is not releasing any information about how incorrect questions affect the score, etc. So I'm not sure, unfortunately. Okay, because they don't even tell us how many we get wrong or if we get any wrong or whatever. They just give us those little bars, which kind of are meaningless. Michael is planning to join a local gym and researching his first option charges a one-time enrollment y-intercept of 60 plus a monthly fee of 18, so 18 per month. So this is my first gym equation. His second option does not have an enrollment fee, so no y-intercept, but charges 30 per month. And how many months will these two be equal? All right, so look at this. We got a system of equations to solve. We can literally substitute 30x in for y. And again, we're trying to solve for x because they're saying the number of months. How many months until these two will be equal? So substituting this in, we literally have the variable we're trying to solve for. So that's perfect. Subtract 18x from both sides. 30 minus 18 is 12. Divide both sides by 12. and we get X is equal to 5. Now let's double check before we hit submit. If I do 5 months, right? 5 times 18 is 90 plus 60 is 150. Likewise, 5 times 30 is 150, so they're both the same. That works. Boom, done. Next. See how I'm double checking everything just to make sure, even mentally. And it's a quite quick check, but you want to do that just to ensure you don't make any silly mistakes. Bill is walking up the steps to Washington Monument at a rate of 30 feet per minute. And Joe is walking down at a rate of 45 feet per minute. Bill is, hold on, let me draw this. So, wait, this is Bill, and he's going up. This is Joe, and he's going down. Let's see if I can draw this out this way. So Bill is 75 feet from the bottom, and Joe is 325 feet from the bottom. Okay. Which of the following can be used to determine the number of minutes at which they will pass, at which they will meet, basically. So I can make an equation, right? So Bill is going up, right? So Bill, let's say his position from the bottom is starting at 75, and he's going up at 30 feet per minute, where X represents the number of minutes he's walking. Okay? Rate of change here is 45, but he's going down, so that's negative. So this one is Y equals negative 45X plus his starting position, which is 325. I'll do this in decimals just for fun. So negative 45X plus 325. Notice I'm excluding the Y, but it'll still work. And then this one's 30X plus 75. So we need to see when these two are going to be equal to each other. And right there. But zoom in, make sure you have the right point. And it's at 3 1/3 minutes. Oh, wait. What am I doing? They just wanted the equations. Sorry. My bad. Should have read that more carefully. So we need 75 plus 30t, which I see in B. And then we need 325 minus 4. It's B. Yeah. Yep. They just had, again, Y was their H, T was their X. I said, did I say B or C? Hold on. Oh, no, I lost it. Oh, man. Shoot. Wait. I lost all that work. Oh, this one was right? 75 plus 30t. Yeah, it's B. Okay, next. All right, Duffy's, okay, again, these are equations, so I don't have to actually solve it. I got to remember this. So Duffy's Copying Center has 2 pricing options for buying photocopies. One option is to buy $40 annual membership. So $40 plus 0.03 cents per copy, which I see in option B. It's got to be B. That's the only one. And then this one is just 5 cents per copy, which I see here. It's B. Last one, the perimeter of a rectangle. I want to show you another rule of thumb. They're talking about a shape. I don't care how easy the problem is. Draw it out. Oh, wow. What? That's bad. Yeah, let's just draw one by hand. They got a perimeter of a rectangle is 148. The length of the screen is 30 feet longer than the width. What is the length? So they want X plus 30, not X. You could also call it W if that's easier. That'll remind you that represents the width. So we got this really great setup. I need to make an equation to be able to solve for X. Well, perimeter, which is 148, equals all the sides added together, which in my representation would be 2X plus 2X plus 60. Now we got a beautiful equation. Let's solve. 2x plus 2x is 4x. I'm going to minus 60 from both sides simultaneously. 148 minus 60 is, what is that, 88, right? Divided by 4x equals 22. But again, that's the width. We need the length, which is 22 plus 32, which is 52. Now let's just make sure that's right. 52 and 22. 52 plus 22 makes 74. 74 doubled is 148. It checks out. Boom, done. Yeah. Okay. That's 6. We got 2 left. 7. Linear inequality. More word problems. No. All right. Trayvon is going to buy a coat and a hat. The coat. Okay, watch this. Immediately I see a relationship. So watch what I'm going to do. coat and hat. It says the cost of the hat is X dollars. The coat costs 3 times as much as the hat. Oh, 3 times X. Look at this amazing equation, or like expression, variable expressions we have. So he's going to buy both of these. He must spend less, so 3X plus X must be less than 94. We're done. Which an equation models this. Now, again, they don't have this exactly, but I know my inequality is legit. So they must have simplified it, which they did right here, because 3X plus 1X is 4X. C is the winner. Done. All right. Next here. To get to school, Daquan walks 0.6 miles from his house to the bus stop. He then takes the bus for 3.9 miles. So he walks 0.6, and then he takes the bus for 3.9. See how I'm making my little table, my little notes, just to get my head around this situation. After he gets off the bus, he can choose one of several walking routes. The total number of miles he travels via walking and bus. After he gets off the bus, total number of miles he does not exceed 5.4 is does not exceed. That means less than or equal to 5.4. So he's got the walking plus the bus. Whoops. Sorry. Walking plus the bus is less than or equal to 5.4, but he's also got this additional route that he's walking. The total number of miles. So he's got this additional route, which I'll call R. So that's the part that we're trying to figure out. What is the greatest possible number of miles he walks after getting off the bus, which I've represented by R? Look at this beautiful equation. All you got to do is isolate. So 0.6 plus 3.9 is 4.5. So R plus 4.5 is less than or equal to 5.4. Minus 4.5 from both sides. Let's do it mentally. R is less than or equal to 0.9. So if it's less than or equal to 0.9, the greatest amount would be 0.9. C is the winner. Done. Next. Hold on. All right. A reservoir can be filled 1/4 capacity in 1 day by pump A and 1/3 capacity in 1 day by pump B. All right. This is A. This is B. Both pumps have a constant flow. Which of the following inequalities best describes the number of days it will take for both pumps working at the same time to fill the reservoir to... Okay. So it's 1/4 per day, meaning times the number of days, plus 1/3 times the number of days. And we need this to be over 7/8 capacity. Okay. It's got to be C. So all they did was they simplified this. So they made common denominators. They made this 3/12. They made that 4/12, and that's how they added them together and got 7/12. But again, I'm not looking at the answer choices and trying to make some sense of them. I'm like, what makes sense to me? I'll create an inequality that I know is legit, and we're good to go. So I think we got them. What did I say? C, right? Boom. Nailed it. All right, last one. Here we go. An outdoor pool can be filled to 20% of its capacity in 1 hour. That can be represented by 0.2. And 10% of its capacity in 1 hour by second hose. Both hoses have a constant rate of flow. Which of the following inequalities describes the number of hours? So it's 0.2 per hour, 0.1 per hour. It will take to fill the pool to over 90%, meaning 0.9 in decimal format. Capacity of both hoses working at the same time. Just create another inequality. And what they did in all these is they isolated H. So again, I'm not looking at these and being like, which one makes sense? Because that's really hard. But instead, I know this one makes sense. Now I just isolate H like they did. 0.2 plus 0.1 is 0.3. H is greater than 9. Divide. Wait, what? Hold on. Well, this is weird. Because I should get 30, not 3. Oh, no. I dropped the point. Whew. Okay. I was like, the answer should be 30. 0.9 divided by 0.3 is 3. So H is greater than 3. A is the winner. And that makes sense, right? Because we're doing 30% in 1 hour, so we need 3 hours. You could also do it that way. Boom. A. Last section. Speed run. All right, which of the following is the graph of the system of equaciones? Okay. Again, you could graph this in Desmos, which I do not recommend. I think it's much easier to put them both in slope-intercept form and evaluate them as follows. Minus 3x, and this one is minus 1 and divide by 2. So we get, I'm doing it kind of quick, right? If I minus 1 and then I divide by 2, it's x over 2, or 1/2 x. Minus 1 divided by 2, minus 1/1/2. So I know I got a negative and a positive slope. I got y-intercepts of 3 and negative 1/2. So negative 1/2 up 1 over 2. And then 3. It's A. It's A. And they intersect at 1, 0. I can also check that 1, 0 is the solution for both. 1, 0, it works. 1, 0, it works. So again, we have multiple ways. That's the beauty of this test. You have multiple ways to attack a solution. You still have Desmos in this option. It's just not the most efficient method, but it's still it works. So that's what I always say. Have a multitude of approaches, and the best one is not necessarily the actual best one. It might be the first one that pops in your mind. Okay, which of the following pairs satisfies the system of inequalities? For these, I like to plug and chug. You could also put this in Desmos and plot these out. Again, not the fastest, but watch how I do it. If I plug in 0 and 5, that works. Plug in 0 and 5 does not work. A is out. Plug in 1 here, 1 here. 1 is not greater than 5 plus 3/10, out. Plug in 8 here, and 3 here. 9/10 plus 5 is less than 8. That works. 8 and 3. 3 times 5 is 15, minus 7 is 8. 8 is not greater than 8, so it's got to be D, but let's double check. 6 is greater than or equal to, wait, what? 6 is greater than or equal to, no, it can't be D. Oh, I must have screwed up. Hold on. 8 is greater than 8. Did I mess up something? Oh, maybe it was this one. No. What the heck? Oh, it is A. Oh my God, that was terrible. 5. Okay, sorry, it was A. I messed up. So be careful, be careful. Okay, so it is A, my bad. So you plug in 0. We get 5 is greater than or equal to 5. That works. Plug in 0 for x, 5 there. 5 is greater than negative 7, which is true. Both of them are true with A. A is the winner. Done. Next, which is the following does the shaded region represent? This one I actually would say Desmos is the best way. So y, here, let's just do it right now. Y is greater than or equal to 2x minus 1. And here we've got y is less than or equal to 1/2 x plus 2. So you got to be careful of the formatting and don't make any silly mistakes. Also, you can hit this home button to go back to the center. So what's the region of, what's the solution set? It's the double shaded region. So it's down here. So we should see an intersection point at 2, 3 and shaded down to the left. So intersection point. It's all the same intersection points, but it's this one. See? Down here. Is there any other way? Yeah, and then you can also verify it this way. So when they say y is greater than or equal to 2x minus 1, the line should be 2x minus 1 and should be shaded above. This is 2x minus 1, and it is shaded above. And then this one is y is less than or equal to 1/2 x plus 2, so we need 1/2 x plus 2, this line, shaded below. So you see it's shaded below this line and above this line. Both lines are solid because it said greater than or equal to and less than or equal to versus less than and just greater than, etc. Last one, here we go. If the shaded region represents the solution set, which of the following could be the system? Now, I am going to actually come up with the inequalities from the equation, and then I'm going to match it. So this line here is y, forget about less than or equal to just yet, but I got a y-intercept of 2, and I got a slope of down 1 over 4, meaning negative 1/4 x plus 2. So which way should the inequality be facing? Since I'm below this line, it should be less than. And it should be less than or equal to, because the line itself is solid. This equation has a y-intercept of negative 2 and a slope of... Wait, I can't be right. I think this graph is messed up. Oh, the intersection point doesn't matter. Never mind. It's not messed up, but the intersection point's irrelevant. Has a slope of down 4 over 1, meaning negative 4 over 1 or negative 4. And again, it's shaded above, so we need y is greater than or equal to. Now, I have my equations. Oh, it's not going to let me move again. Hold on. Grr. This thing is terrible. Hold on. I don't know how to move this. Okay, I'll just try and remember. It's fine. So y is less than or equal to negative 1/4 x plus 2. There it is. Or that's the first one's correct. And then the other one was supposed to be greater than, not less than. So it is C. Yeah. Unless I made a mistake. That's it, ladies and gentlemen. We have gotten 1 through 8. And then we're going to go on to problem solving and data analysis, which I'll tackle either tonight late or tomorrow morning again. Because as I mentioned, I'm going to try and get all the medium done by this weekend. Also, let me know in the comment section what you want to see for the rest of the week. I'm obviously going to make my predictions video Friday. I can also do a big Desmos video if that's what you guys are interested in. Or alternatively, just focus all my attention on these problems. I do want to say that I will say that these questions, while they've gotten better, some of them still miss the mark in terms of matching to the content and like sort of nature and setup of the actual College Board SAT questions. Your first resource, again, I've done all those problems on this channel already, but your first resource should always be the practice test 1 through 6 from the College Board, as well as PSAT 1 and 2 that you can get on the Blue Book app. But this is a nice supplemental resource. They've also got amazing problems on the digital SAT question bank, so I would definitely check those out. All right, ladies and gentlemen, that is it. Thank you guys so much for joining, and I will see you in the next video. Take it easy.